This is the screencast for section 2.8, example 8, solving an inequality involving absolute value. So here's another kind of function that you don't know exactly what it looks like, but you're going to be able to tell when it is above the x-axis and when it is below the x-axis by testing the critical values on the number line. So critical values are positive 2 and negative 3. Negative 3 makes the denominator 0, so it makes the function undefined. Positive 2 makes the numerator 0, so it makes the whole thing 0. Now, I'm going to pick a number to the left of negative 3, and you know what? No matter what that number is, left of negative 3, between negative 3 and 2, after 2, the absolute value is going to make the denominator positive. So all across the board, I can write positive in for my denominator. All I have to worry about is what my numerator will be. So an x value to the left of negative 3 is going to make the numerator negative. An x value between negative 3 and 2 is going to make the numerator negative. And then an x value after positive 2 is going to make the numerator positive. So overall, I have negative values here, negative values again here, and then positive values there. So to answer the question, where is this rational function less than or equal to 0? Let's see, less than 0 is going to be negative infinity to negative 3. I'm not going to include negative 3 because negative 3 makes the function undefined, not 0. But then again, from negative 3, oh, that was negative 3. From negative 3 up to 0, up to 2, but I'm going to include 2 this time because 2 does make it or equal to 0. I'm going to graph this on my calculator. Oh, look, there it is. So you can see there are negative values up until the vertical asymptote at negative 3, negative values again after that, and finally at the x value 2, the y values become positive going above the x-axis. So I checked my solutions graphically. The now try problem for example 8 is number 53. We've got 3 critical values and whoa, absolute value and square root. Miss Larson, you're going insane. I know. So my critical values are 5, 2, and then the denominator would be 3/2 would make that 0. So I'm going to put those on the number line. 3/2 makes the denominator 0, so that would be undefined for the entire function. 2 makes the numerator 0, so the whole function would be 0. And then 5 also makes the numerator 0, so the whole function would be 0. Alright, so I've got 2 portions in the numerator and 1 portion in the denominator, so I'm going to make that shape across my number line in each section. Now I've got absolute value in the top right, so no matter what I plug in to absolute value, the output of that is going to be positive. So I'm going to put positive in all of the top right portions. Now, I'm going to worry about what's going to happen with my square root here down in the denominator. To the left of 3/2, so like negative 100. 2 times negative 100 minus 3 is going to be negative, and I can't take a square root of a negative. So this is going to be imaginary, so I'm going to have no graph to the left of 3/2. Now 3/2 won't make the function imaginary, it'll make the function undefined because it makes the denominator 0. After 3/2 though, I don't have anything more to worry about in the square root. As a matter of fact, any number I plug in after 3/2 is going to make a positive value in the square root, and then the square, so that therefore I can take its square root, and then the square root of that would be positive. So now I'm going to have positives all the way across with the square roots too. Top left, now I got to really think about what I'm doing here. If I plug in 1 minus 5 is negative. If I plug in 3, which is between 2 and 5, 3 minus 5 is negative. And then if I plug in anything bigger than 5, I get a positive. So between 3/2 and 2, I will have a negative y values. Between 2 and 5, I will have negative y values. And after 5, I will have all positive y values. So to graph, let's see, to answer the inequality, what makes this function greater than or equal to 0? Greater than or equal to. So that's going to be x equals 2 and including 5 all the way to infinity. And of course, I want to graph that on my calculator to make sure that that messiness was analyzed correctly. So you can see that around 3/2, the function actually starts graphing. It hits the x-axis or becomes 0 where x equals 2, drops down to negative values again, and then goes up to positive values after the x value 5.